So welcome to lesson 2 of unit 2, and the only section we're going to cover in this lesson is the one on classification of matter. So we have talked about how matter changes. Now we need to get into how it is classified. So the atom is the smallest unit. Smallest unit that maintains the chemical identity. That maintains the chemical identity. And then we have an element that is a pure substance that can't be broken down. That can't be broken down. It's an N, sorry about that. Into simpler, stable substances and it is made of one type of atom. One type of atom, though it can be many. And again, it can have one or more atoms of the same kind. So that's why the atom is actually the smallest. Atoms make up your elements. Example, carbon is an element containing one kind of atom. All discovered elements are represented on the periodic table. Next is a molecule. It contains at least two atoms held together by chemical bonds. Okay, chemical bonds. Molecules may contain two or more atoms of the same element. Golly, this pen is hard to write with. Same element. Or of different elements. Okay, and we'll talk about this distinction a little bit more when we get down to compound. So, a diatomic element, it's the term for the elements that exist in nature as molecules formed from two of the same atom. That exist in nature as molecules formed from two of the same atoms. And I'm sure you realize that di means. You'll notice I have a list here. You may well be expected to know this, especially when you get into the college level, that these elements are found as diatomic elements. And in fact, most elements are not found alone in nature, but these will be found in pairs like that. And some of your noble gases as well. And then up here's a little note: virtually all substances that are liquid at room temperature are molecular substances, and most matter is composed of either molecules or ions. So we'll get to ions either in this lesson or the next, and then we'll really talk about molecules and ions and their states when we get into bonding in the next unit. Vocab word for you: allotropes. They are different forms of the same element. Different forms of the same element. Okay, so for example, carbon. Carbon allotropes are graphite and diamond. Both very different in their properties. They're both solids, but they are very different. Allotropes will usually have different bonding arrangements, different chemical and physical properties. And they only occur with certain elements in groups 13 to 16. And the list really isn't very long, but carbon is one of the most well-known ones. Sorry about the dogs in the background. Someone just got home. Okay, and a compound is a substance that can be broken down into simple, stable substances. Each compound is made of the atoms of two or more elements that are chemically bonded. I always think of the C's. A compound starts with a C and chemically bonded starts with C. Two or more elements that are chemically bonded. Now, just because it can be broken down into simple, stable substances doesn't mean you can simply break it down. It takes some work, and it takes chemical means, not just a physical separation. So, reflecting back on the definition of molecule just a few minutes ago, you could say that all compounds are molecules, but all molecules are not compounds. Okay, because you can have molecules that are made from only the same element. Okay, so when you get into two or more elements, you're dealing with compounds, which are also molecules, but all compounds. You cannot say that compounds are molecules. I know that sounds picky, but that's a perfect spot for people on these MCAT tests and things like that to really mess with you and make sure that you know the difference there. Atomic are two of the same. It looks like my picture got a little bit in the wrong place. I'm not sure if this is lining up with yours, but this was supposed to go below all these words. But anyways, here's your example of the previous term, molecule. Compound. Water is a compound made of two elements, hydrogen and oxygen, and it is also a molecule. Okay, now let's move into mixtures here, and then we can come back and look at that picture for a second. So a mixture is a blend of two or more kinds of matter, each of which retains its own identity. Each of which retains its own identity. And properties. So it is a physical change that occurs when a mixture happens. Some examples are the air that we breathe. That's a mixture of different gases and particulates. Sweet tea, wood, even and blood with your platelets and your plasma and the different components there. You've got two types of mixtures that do often show up on different assessments that you may deal with. So we have a couple of types of mixtures. One is a heterogeneous mixture, and I just discovered I have left the E out. That goes right there. After that N, sorry about that, heterogeneous mixture, and it is a mixture that is not uniform. So I'll use my little slash thing. That is not uniform throughout. And you'll notice your prefixes here. Hetero means different. Remember heterozygous traits from biology. Some examples are a tossed salad, no-bake cookies, blood, anything that is physically combined and yet you can separate it and see that it is not combined uniformly, it's not all the same, then that's going to be a heterogeneous mixture, as opposed to a homogeneous mixture, and that is a mixture that is uniform throughout. It is uniform. Sorry, I'm just going to mark that out. Uniform throughout. And it is also known as a solution. You will hear solution, solution, solution over and over and over in chemistry. You will not hear people saying, oh, that is a homogeneous mixture, but you will talk about solutions a lot. Again, homo means the same, and remember homozygous traits from biology, just to try to link back to where you've heard that prefix. Some examples are sweet tea, chocolate milk, even salt water. Okay, salt water is a good one. Anything that you take something and you mix it up and it's going to be dissolved, basically, is going to be a homogeneous mixture or solution. So if you take a drink of that salt water from the top, it's probably going to taste pretty salty. And you take a drink from the bottom, it's probably going to taste pretty salty because it is a uniform solution where the little salt particles have disassociated and spread uniformly throughout the water. And so how is a solution different from a compound, you may be thinking, if you're actually really thinking about this? They sound like the same thing, kinda. Okay, so I know I usually say do not use answers.com, but as I was looking for a good source to put this into good terms, I actually ended up liking the one that I found on answers.com for being the easiest to understand. So solutions can be separated by physical means. Physical means. Like boiling, chromatography, which we'll talk about when we do our flame test. Boiling, chromatography, filtering, and so on. Anything that's a mechanical or a physical separation is going to be a solution. While compounds can only be broken down into smaller compounds or elements by chemical means. By chemical means, like electrolysis or combustion. Once a solution is separated, it's generally easy to turn it back into a solution. Just mix it back up. A compound, once separated into elements, though, requires another chemical reaction to turn it back into the initial compound. Let's just take a quick look at our flowchart here. Our concept map really is what this is, and your concept, your main idea here is your matter. It's your main word. It can be divided into mixtures or pure substances. If it is a mixture with more than one kind of atom or molecule, you can have a homogeneous mixture or a heterogeneous mixture. And here's where we have water and sand as their example. And here, just sugar dissolved in water is their example of the homogeneous. Then over here, if it is a pure substance, meaning one kind of atom or molecule, that can either be an element, where you just have a single kind of atom, but more than one of them, or a compound, where you have bonded atoms that are more than one type of element.